right, Precalc, we're moving on with Chapter 2, Section 3, and we're moving on to a factor theorem. The factor theorem, last year I told you over and over and over again, when the remainder is 0, it is a factor. So keyword, it is a factor when the remainder is 0. We're going to use synthetic division for all of these. Don't forget that there's no x squared here, so we have to put a 0 in. I'm going to set this up with the 0, which would be -3. There's an invisible 1, the 0 for the x squared term, a -19, and a -30. Remember, it is a factor if the remainder is a 0, so that's why I showed the 0 right there. Drop the 1, multiply, add down, multiply, add down, multiply up. The remainder is a 0. So yes, x plus 3 is a factor. Moving on to using the remainder theorem in synthetic division. There's a couple of things that we need to know. Number 1, the remainder r gives the value of f at x equals k. R is equal to f of k. If r equals 0, number 2, if r equals 0, x minus k is a factor of f of x. If r equals 0, k 0 is an x-intercept. So let me put that in real people terms, okay? So let's say I was looking at oops, I need my pen. F of x is equal to, I'm just going to keep it simple, x squared plus 7x plus 10. So if this is the case, if this is what I had, plus 10, I know that this can be factored to be x plus 2, x plus 5. And that is where they say they are a factor. So let's look. Oh, it's right here. They're showing it right here. X minus k is a factor. So these are called factors right here. When I actually take the time to solve, meaning I'm going to set each of these up to 0, x plus 2 equals 0. So when I subtract 2 over, x is -2. X plus 5 equals 0. When I subtract the 5 over, x equals -5. These are called the zeros. So right here, these two are called zeros. But the last thing they're telling us is if we put them in little points, -2, 0 and -5, 0 are also called x-intercepts. So here's where it gets really tough. Hopefully you have a good Algebra 2 background. We called these the P's and Q's. The P's and Q's, where the last number, all the factors would be the P's, and the first number, that's why I had it underlined, in this case it's just a 1, would be all the Q's. So they're telling us to find the rational zeros of f of x equals x cubed minus 5x squared plus 2x plus 8. So what we're going to do is we are going to find all our P over Q's, but I have to write all the factors of 8. Well, 1 and -1, 2 and -2, 4 and -4, 8 and -8 all go into 8. The only factors I have of 1 are 1. So if I take plus or minus 1 into plus or minus 1, we're dividing. All my factors, I'm just taking this 1 and dividing. Sometimes you get like a 3 over 2. You get some weird ones. We are dividing all of these. So I know that plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8 are the possible zeros. And I always used to say, possible. These are only the possible zeros where I actually have to find the real zeros. So what I do is I tell my students you could check all of these with synthetic division. We know it's a 0 if the remainder is 0 with synthetic division. Or we can go ahead and plug this into our TI. So I'm going to give you a moment to plug this right here into your TI at the y equals. When you graph it, you could see that it goes through -1. So I'm guessing, again, I'm guessing that -1 is a 0. How do I verify? I'm going to plug it back in. 1, -5, 2, and 8. That's our bell. I know if the remainder is 0, it is a 0. 1, -1 times 1, add down, multiply up, add down, multiply up, and it looks like -1 works. So I'm going to circle that in yellow. This one works. Let's try. Well, if I look at my calculator going through the x-intercept, it looks like that 2 is going to work as well. So I have to do the exact same thing with synthetic division. I know if it has a remainder of 0, it's a 0. Add down, multiply up, add down, multiply up, add down, multiply up. 2 also worked. And the last number when I'm looking at my calculator looks like 4 is working. So I'm going to check it and verify it by plugging it in. I know it's a 0 if the remainder is 0. 1, multiply up, add down, multiply up, add down, multiply up, and it looks like 4 works as well. So in this case, they told us to find the rational zeros. So I know that my zeros are at -1, +2, and +4. Now remember, those can also be written as x-intercepts. So if you look above, you can write it as x-intercepts. The next question is where it's going to get really hard for us. So I'm going to encourage you to find your p's and q's first. Well, my p's are all of the factors of 14, ±1, ±2, ±7, ±14. We lucked out again that we just have a 1. So I know all the numbers that could work are ±1, ±2, ±7, ±14. So once again, put this in your TI and see if you can, we're going to put this in, I'm going to circle it in yellow, at the y equals in your TI, and let's see what actually works. In my calculator, it looks to me as though it's going through some weird numbers. So I'm going to write these down. -2, it definitely looks like it's going through. And then like just under 1. So I don't know what number that is, and that's why they're talking about the real numbers, because these could be square roots. They could be weird fractions. It also looks like it's going through 7. So the first thing I'm going to do is I'm going to try -2 using synthetic division. I have to put my numbers across. Same thing. I know it's a 0 if 0 is the remainder. And I'm going to do this quickly, hopefully without any mistakes. And it looks like -2 works. Now, it also, let me go ahead and circle that in yellow. This one works. It also says that 7 works. So I'm going to go ahead and continue with a 7 here, because now this kind of makes it a little shorter. Add down, multiply up, add down, multiply up. Well, that didn't work. What happens if I tried it this way with the numbers across? 1, -7, -11, 14. 1, multiply up, add down, multiply up, add down, multiply up. Notice that doesn't work. So -2 is the only one that I could use that works. But right here, I get the answer, what happens when I divide the factor of x plus 2 into this polynomial. So I can go ahead and use x squared minus 9x plus 7 as one of the factors. It is a factor, but I can go ahead and use that quadratic formula. You can complete the square, use the quadratic formula, but I prefer the quadratic formula. Remember, my a is 1, my b is the second number, -9, my c is the constant, which is 7, x is equal to opposite b plus or minus square root. B squared is 81 minus 4 times a times c all over 2a. So I get, well, 81 minus 28 is 53. Yep, there's that weird part I told you about. So it looks like my two other factors, I know there's 3 because of this number right here, this x to the third. And they are real zeros because remember they said they might not work out perfectly. Well, guess what? They didn't. I had one answer at -2, and my other answer is right here. So I would have to show that as 9 plus or minus the square root of 53 all over 2. Now remember, if that square root can reduce, to go ahead and reduce that, okay?